Welcome everyone. For today's prep, we're going to start to look at a few new differentiation rules. And the first one we're going to look at is called the product rule. So, let's take a look at what the rule says and how we use this. So, what we're doing here is we're trying to differentiate the product of two functions. So that's what this is telling us. We've got one function f of x, so there's some variable stuff there. And we've got another function g of x that we're multiplying. And we want to differentiate this entire thing. So we want to see how to differentiate this entire thing. And we've looked at rules, some differentiation rules, where maybe we have a plus sign in between those two different functions, or maybe we have like a minus sign in between those two different functions. But now we're going to see how to handle multiplication. So this is something new. So how do we differentiate this product? Well, let's read through the formula and then kind of describe a way to hopefully help remember this. So we have this product. It's the derivative of the first function. We leave the second function alone. And then we add in the first function unchanged times the derivative of the second function. So we do eventually differentiate each of these terms individually, but there's a little bit extra going on here because we end up with two copies and then there's this plus sign in the middle. So let me go over a way to kind of remember this formula so you don't necessarily have to just have this memorized. You think of it more as like a process. All right. So we have a product that we're trying to differentiate. We've got some variable stuff here. We've got some variable stuff here. And we're multiplying. We want to differentiate. So the way we do the product rule, or way to kind of remember the product rule, and this is going to be helpful later on as well, is we have this product. So the idea is we're going to write down two copies of that product, f of x times g of x, and then leave a space, and then we'll write down a second copy, f of x times g of x. And then in the first copy, we're going to apply the derivative to just the first part of our function. And then in the second copy, we apply the derivative to just the second part. And then in the middle, we put a plus sign. So that's our product rule. All right, so let's try an example, and then we'll come back and talk about this warning here. All right, so let's try differentiating this function. So we've got this function y. It's equal to 2x cubed minus 5x times 3x plus 1. So what do we have here? We've got a product of x terms. We've got some x terms here. We've got some x terms here. And it's not explicitly written. So it doesn't actually, we don't have a multiplication symbol there, technically, but it is there. It's not explicitly written, but it's there in the middle. So we're multiplying these two x terms. All right, so we're going to use product rule for this. So let's try it out. So our function's called y, so let's call our derivative y prime, and then we're just going to write down two copies of this product, as is. So 2x cubed minus 5x times 3x plus 1. So there's our first copy. Leave a little bit of space. And then let's write down our second copy. 2x cubed minus 5x times 3x plus 1. And then on our first copy, we're going to apply the derivative to the first part. And then in our second copy, we're going to apply the derivative to the second part. And then we put a plus sign in the middle. So that's the product rule. And then once we've done that, then we just finish differentiating each of these. And each of these now are just regular basic derivatives that we can just do. So let's see what we get. So for the first one here, let's look at the 2x cubed. We just do our basic power rule. So we bring down the 3, multiply it with the 2. So we get a 6x, and then we subtract 1 in the exponent. So we get a 6x squared. Derivative of that minus 5x is just going to be minus 5. The 3x plus 1 was not inside the bracket there, so that stays the same. Same thing with the plus 2x cubed minus 5x. So that part we're done with. And then we just got to finish differentiating the 3x plus 1 here. So derivative of 3x is just 3. And then the derivative of that plus 1 is just 0. And we're done. That's it. That's our derivative. Now, one thing with doing product rule is we just got to remember parentheses. So a lot of these parentheses are important. We need these. We need this set. We need this set. We need this set. We don't really need the ones around that 3. So we could have just left this 3 as kind of out in the open there. Whenever you're adding or subtracting stuff and then there's multiplication, you just got to be aware of the order of operations. So we want all this stuff in here to get multiplied by 3x plus 1. So we have to put it inside parentheses. So just be careful with parentheses. It's better to use them than not. All right, so as you can see in this example, it's really tempting to think, when we do product rule, to think, oh, I got one function f of x, I got some variable stuff. Then I got a function g of x, I got some more variable stuff, and I've got multiplication in the middle. So it's really tempting to think, well, let me do the derivative of the first variable portion, do the derivative of the second variable portion, and then just multiply the results together. And unfortunately, that's not true. It's not the case. So, very natural thing to think, very reasonable thing to think. It's just not correct. So, notice in this example, we did eventually differentiate the 2x cubed minus 5x, but it was attached to some other stuff here. So, just to kind of show you what a wrong answer would look like for this case. Let's do it incorrectly. So what would it look like incorrectly? Well, we'll call our derivative y prime, and then let's differentiate this portion. So we're still going to get that 6x squared minus 5. And then let's differentiate this portion, so we'll still get the 3, but this is incorrect. So we've done it incorrectly there, just to show you what wrong approach would look like. It's really tempting to think, let me do this derivative, and then I just multiply the results together. Because that's really how it works with addition and subtraction. So if this was an addition sign, then that's exactly how you would do it. You would just differentiate this, and then keep the addition sign or the subtraction sign in the middle. But because this is multiplication, there's a little bit more going on. So this is incorrect. So you can't do that approach, unfortunately. All right. So we'll practice a little bit more of this in class. But I want to switch over to the next differentiation technique, kind of related to product rule, and that is quotient rule. So this tells us how to differentiate a function when there's a quotient, when there's a fraction. So let's look at what the rule says here. So we use this rule when there is a fraction going on. So we've got a top function, f of x, we've got a bottom function, g of x, and we're dividing one by the other, and we want to differentiate that whole thing. So how do we do this? Well, there's a special formula, just like with product rule, and actually this is kind of related to product rule. So when we go through this, it'll kind of feel a bit like product rule. It's a little different, so you gotta be careful. So what do? Well, we differentiate the top function times the bottom function, then subtract off the top function times the derivative of the bottom function, and then we make this into a big fraction and we square the denominator. So we can kind of, rather than trying to memorize the formula, we can kind of think of this as a process just like we do with product rule, and it'll feel very similar to our product rule. So let's try this and just go through how we're going to do it. All right, so let's try the quotient rule here. So the idea is we're going to rewrite this fraction as a product. So we'll do the top function times the bottom function. And then just like product rule, we do 2 copies of that. So let's put another copy over here. Leave a little space, and then we'll do top function times the bottom function. And then just like product rule, in the first copy, we apply the derivative to the first portion. first portion. And then in the second copy, we apply it to the second part. So very similar product rule. Now, where it goes a little different, in product rule, we put a plus sign in the middle. Here, we're going to put a minus sign. So it's a little different in that regard. And then we make this into a big fraction, and we square the denominator. All right, so in case you forget it, there is also a way to kind of, there's a little rhyme. If you want to remember the little rhyme here. So let's see how does it go? Okay. So it's low D high minus high D low. Draw the line. And you square the low. So if you need a little rhyming scheme there, it can kind of help you remember. So what are you doing here? Well, it's the bottom function times the derivative of the top minus the top function times the derivative of the bottom function. So low D high minus high D low. Draw the line, square the low. All right. And again, notice there's a similar warning with quotient rule. So it's very natural to think, well, let's just differentiate the top of our function, differentiate the bottom of a function, and just keep the division sign the same. Unfortunately, it doesn't work like that. So it's very tempting, but this is incorrect. All right, so let's try an example. So we've got this fraction, 4x squared minus 6 over 3x plus 1. And we've got some variable stuff on the top. We've got some variable stuff on the bottom. So not all fractions do you have to use quotient rule for. We'll see a couple examples in class where you don't actually have to use them. You only have to use quotient rule if there's variables in both places, the top and the bottom. All right, so we're going to do quotient rule on this one. So let's try it out. So our function's called y, so let's call our derivative y prime. And when we do this, we're going to rewrite this fraction as a product. So we'll do the top function times the bottom function in that order. Remember to use parentheses. And then we're going to do a second copy, leave a little bit of a space. So top function times the bottom function. Keep the order the same. And then in the first copy, we're going to apply the derivative to the first part. And then in the second copy, we're going to apply it to the second part. And then with quotient rule, we put a little minus sign in the middle. And then we make it into a big fraction. And we take our original denominator, which was 3x plus 1, and we square that whole thing. All right, so now we just finished differentiating. So 4x squared minus 6, we can just focus in on that, and this is just a regular derivative now. Nothing too fancy here. So derivative of that 4x squared is 8x, and the derivative of the minus 6 is just 0, so we end up with 8x. And then we've got our 3x plus 1 minus, and then we've got our 4x squared minus 6, and differentiating that 3x plus 1, we get a 3 plus 0, so just 3. And then we make this into a big fraction again, and we've got our 3x plus 1 squared in the denominator. And don't actually multiply that out. So just leave that as 3x plus 1 squared. Don't multiply this out. And then one other thing, just remember parentheses. So here, I've probably got a few extra sets of parentheses. Because it's just 8x, there's no addition or subtraction here. I don't really need these parentheses, but I do need these. Same thing over here. I do need these because there is this minus sign, so we've got multiple terms here. But I don't really need the parentheses around that 3. And then same thing, I do need the parentheses here. So same with product rule, just be careful with parentheses. And again, for a quotient rule, don't actually do the multiplication. Don't multiply this out. Just leave this alone. Don't touch the denominator, essentially. All right, so we'll get a little bit more practice of this in class. So we'll see you then. Bye-bye.